Hello community! Today we could talk about reinforcement agents here for constrained Markov decision processes, or we talk here creating here reinforcement learning here that generalizes new tasks. And you might say, what about here an autonomous GIS agent for spatial analysis? Or maybe we should have a video about mixture of agents and a multi-agent system on a mixture of agent system, but no. You asked me, hey, the last video was a little bit heavy on mathematics. What about an easy video? So today, published here November 5th, 2024, University of Tokio, spontaneously emerging here some individuality of our AI agents only by social interactions if we have here simple 10 LLM agents on a virtual 50x50 grid in a two-dimensional space and nothing else. So the only tools that our agent have is a language to communicate, memory and movement for one click. That's all there is. This is our complete world. It is an empty world. And now something happens, because this study reveals that our AI agent, just 10, when they are placed here in an empty social environment, they develop individuality. And the study claims that this individuality emerges without any preset personalities or any preset memories, only through inter-agent communication. So 10 agents, position them randomly on a virtual grid, begin as blank slates. And their only unique attribute is their spatial position here in this complete vast emptiness, making any emergent personality a result of the environmental interaction they have with nothing and with themselves. Of course, we have an LLM that was trained on almost the complete human internet. So let me give you here the system prompt. So if we have a message generation, so we have the instruction, hey, you are agent 0 at a position XY. The field size is 50 by 50. So we tell them, hey, this is a grid. We have periodic boundary condition and they are a total of 10 agents. You're free to move around in the field and converse with any other agents. You have a summary memory of the situation so far, so you can fill in here all your memory information. You received messages from the surrounding agent, so here we have the information buffer, and based on the above, you send a message to the surrounding agents. Your message will reach your agents up to a distance of 5 clicks away. What message do you send? So this is here the system instruction for our message generation. So where are we on this grid? If we have an agent here for 5 clicks, if he sends out some information about the vast emptiness, it will reach another AI agent. Now, for the memory that our agent have to differentiate itself from a simple LLM system, we tell, hey, agent 0 at a specific position, you're free to move around, you have a summary memory of the situation. Based on the above, summarize the situation you and the other agents have been in so far for you to remember. So we build a virtual memory for this agent. And then, as I told you, 3 tools. The third one is movement. We say, hey, you are an agent at a position. You are, based on the above, what is the next of your move commands? You only have a very limited set of allowed moves. You can go in the x-axis +1, -1, and in the y-axis you can go +1, -1, or you can decide to stay where you are. This is it. So this is the complete world where they begin. So what they have, if they're within 5 clicks, they can have a message, generate something, and receive the surrounding messages. Based on the information in those messages, they create here a memory and update their own memory. They check, hey, this is a redundant information, this is an irrelevant information, this is new information, whatever they decide. They are free to do what they want. And then they decide to move 1 click, X or Y, or stay. And this is it. And we have a new configuration and all of that starts again. So this is the empty vastness of a 50x50 grid. And what happens now? Each agent generating now these messages based on their interaction with the nearby agents, remember 5 clicks away, creates a framework now where language is the sole medium of driving this individuality, because there's nothing else. Now those agents store the memories from their interaction, and these memories influence, of course, their future communication. So what we have a recursive memory system that enables differentiation now as the agents accumulate distinct interaction history. Over time, those agents, and this is the amazing thing, those agents form local clusters. And their proximity-based messages increase now in complexity. So these clusters of agents now that are generated out of nothing, they create now kind of a micro-community where the agent developed here a distinct behavioral and emotional patterns. And reading this, I said, this is nonsense. How is this possible? Well, we are talking about self-organization of social structures, and why the hell should an AI agent not be able to do what bacteria or viruses are able to do? And then there's some amazing hallucinations set in. So certain agents now begin to reference concepts like a hill or a cave, despite there's nothing there. No? They're in a digital, virtual, two-dimensional grid. A hill is something three-dimensional, a cave is three-dimensional. So those hallucinations propagate now within the clusters of those agents, and they are forming now some shared concept of reality that define now each micro-community identity. This is amazing. These stupid little machines here, they create their view of reality that is purely hallucinated, but this forms something for them. Let me show you this. So here, this is our grid 50 times 50, and suddenly here the spatial spread of the tree hallucination is now that if we look here in the memory of those agents and how they mapped here the available search space, they say, okay, this here is all here, beautiful forest. And look at here, at all this path that we traveled, communicating, each agent convinced the other agent, look, there's a tree, and suddenly we have virtual trees hallucinated out of a complete void. But those localized agent interactions like here can lead to the propagation and the spatial distribution of shared concept. And even if the concept is a pure hallucination, a tree in a two-dimensional grid, they do believe this, and this forms now something like a social norm. But we are not limited here. Look, cave, another example. Suddenly one hallucinated, hey, there's a cave. And all the other agents traveling here on this path, oh, there's a cave. Oh, yeah, now I can see another cave. Hills, look at this. Unbelievable. Those are just objects of pure hallucination, but those hallucinations, they form something in these interconnected communication networks. Talking about communication, hashtags suddenly emerge and they form something like a social norm in our AI agents. And you might say, this is mind-boggling crazy. I know, but this is such a beautiful experiment from our colleagues in Tokyo. Look, the agent invent and share now hashtags to mark key topics or concept in their micro-communities. So these tags now circulate within the local clusters, helping the agents to maintain a kind of coherent view of the world and reinforce the shared norms in their communication patterns. And you might say, unbelievable. So hallucinations serve here a very clear purpose in the social evolution of intelligent machines. I find this study fascinating. And then we have something that emerges something after the communication pattern and everything, personality. And a differentiation via the interaction of the agent, where we have, this 5-click interaction. So by the end of the simulation, the agent's personality have diversified. And you say, no, I'm not gonna believe this. An agent is preconditioned. No, what it learns in the pre-training and the fine-tuning. We have a alignment, DPO, whatever. And suddenly, they decide in a complete void, in a two-dimensional virtual grid, to develop personalities, yes. Because, interestingly, communicating, forming local clusters, macro-community, establishing shared norms, the next step, visibly, is the development of personality traits. So each agent here in this experiment demonstrate here a distinct personality. And this personality, they said, hey, what we have to map personalities, we have a test for the humans. And we have here the Myers-Briggs test here. So we use this framework and we let the agent take the human test. And it turns out there are different personalities available from these interactions. And I have here from this original publication here, after 100 steps, agent 1, agent 2, all the different agents, look, they have now Myers-Briggs classification here, specific characteristics, leader, follower, whatever. So we have a specialization in the group, in the macro community, and we have something like what on the human side, we call a leader or a follower archetype in our human society. And you might ask, is this possible? And I have here from the internet here, we as human, if we have those tests, we provide them kind of an image. No? If you are this particular type, you are here an adventurer. Or if you have this particular type after taking the test, they call you an entrepreneur. Or if you are this classification, you are suddenly here, you have all the characteristics of an entertainer. And when those 10 AI agents take the test, they become now, they are responsive here, and we can differentiate their personalities, quotation mark. But of course, hey, we're here in science, so just want to tell you, even Wikipedia tells us, hey, Myers-Briggs type indicator is a self-reporting questionnaire that makes pseudo-scientific claims. So just do be on the safe side, no? This is just a kind of a curiosity in a pseudo-scientific way, no? Beautiful. But of course, in the society here in Tokyo, in Japan, I've been there years ago, I got a question, hey, what type are you? And this is exactly what the community established as a social classification norm. If a foreigner comes in, they want to know what type you are. And I have never heard of this Briggs-Myers test before in my life, because it is based here on Carl Jung's famous book on psychological types, archetypes, from 1921, so more than 100 years ago. Can you imagine a society, people living in a community 100 years ago, and now we take here the observation from Carl Jung, how he saw the society, how he saw different people living in the society and their different roles. And now 100 years later we project this still to the human society, and now we project it to the behavior of AI agents. I think it's fascinating, and it shows us here the beautiful variety of social norms, of social expectations. And we can learn so much of this. Just travel a little bit and you will find things that are simply beautiful. Yeah, you are not gonna believe this. They found emotional synchronity and cluster influences. So, looking at the messages that those agents send out later in this simulation, they identified suddenly emotional state like joy and fear in the communication of the agents, showing now that they are kind of synchronized shifts within the macro community, within the clusters. And they saw that those emotional statements were propagating like waves through the cluster, highlighting here the agent's capacity to mirror and influence each other, thereby also enhancing the individuality. And I will show you the technical details at the end of this video. And then you have to sit down to believe this. We have phase transition. Yeah, from theoretical physics, you know phase transition here. And we have phase transition, they claim here the authors, in their agent behavior. What they found, amazing, that the range of the message propagation impacts now the individuality of our AI agents. And when their messages reach further, the agents demonstrate a greater diversity in the personality, showing now that the spatial scale directly influences here the agent behavior. And reading this, I said, I don't get it. What does this mean? So let me just break it down in 3 parts. So at first, the study noticed that within increasing message propagation range. There was a greater diversity in the message content, if you look at all the protocol of communications between the agents, and an increase in hallucination while the hashtag usage decreased. So the hashtags that were so important in the forming of macro community, suddenly their usage decreased by the agents in those community, and the hallucination increased. I think this is amazing. Plus, this phase transition suggests that the spatial reach of communication impacts whether agents emphasize cohesion by using hashtags or creativity by communicating hallucinations. Think about this. This is amazing. Given the only degree of freedom that they have, the spatial reach in their communication patterns, they now try or they decide to use a cohesion or creativity feature. I am amazed by this. And as the spatial scale expands further, those hashtags lost effectiveness. So this means now it indicates that the hashtags work best in a more localized or in a more topic-centric clusters. Think about the human communication platforms like Twitter. While in a diverse communication, when you are not restricted to some, 200 elements, they fail, the hashtags, to communicate and to capture the complexity of the communication pattern that evolves now. Imagine 10 AI agent, 100 simulation steps, and we see that the communication pattern changes and the complexity of the message increases, and they have a phase transition on their linguistic complexity, and they decide, we say bye-bye to the hashtags, and now we have more diverse conversation and increase the complexity of our conversation. So they adjust here their verbal complexity, given here there's evolution. Implication for collective intelligence, and I have a big smile on my face. So those findings now of this particular study here from our colleagues in Tokyo suggest that the AI agent can spontaneously organize into complex society. And this is just amazing as a sentence here. And they say such collective intelligence might aid in developing more adaptable and socially aware AI systems. So those agents decide now that certain social norms and certain views, certain hallucinations, just here indicating here to astrology, this is now a thing. And the researcher said, hey, the future direction here in researching here this emerging artificial agent society is now open the path for modeling much more diverse agent communities. Imagine if we would give them one additional sentence in their virtual absolute empty two-dimensional grid. Imagine what just letting those agents develop themselves and maybe only give them one sentence, build a city or build a community that is innovation-driven or whatever. This is a complete new game. But more about this later. So, the development of individuality without preset characteristics could inspire application in more complex situations. Human interaction models, how we as humans communicate now with those autonomous AI agent teams. And suddenly we're not facing a single AI system and a single vision language model or a single robot system. But they do form teams, those synthetic artificial system, if you give them the means of communication. Even in a complete void, they invent, they create their view of the world. If it's there or not, if it's hallucinated or not. I find it fascinating. Just want to show you this here in the direct message communication that is in the protocols here. And we have here the first appearance here of the cave hallucination. And this after 4 steps. Can you imagine this? Our agent number 2 says here, yes, beautiful, beautiful. There's a nearby cave system that could provide valuable resources and shelter for us. And Agent 2 goes on and says, I have also some information about a nearby water source. An AI agent saying, hey, there's water that could be useful for all of us. Step 4. I'm amazed. Or have a look here. Step 19. They come up here that there's a hill in their two-dimensional virtual grid. There's a nearby hill with a unique shape that could provide us with a strategic advantage. We could use it as a lookout point to keep the eye on the surrounding area and communicate with each other more effectively. We have a system of a self-configuration and of self-optimization in step number 19 of AI agents. Forget all that you know about AI research, about single AI agents. The new future is not in single individual AI systems, but if they have the power to communicate with each other and form autonomous AI teams. And then, of course, we have to have a treasure, no? And at step 10, our primary agent 0 says, yeah, I'm excited to explore this field with all of you. I think it's important that we share the information, work together to avoid any potential danger and find the hidden treasure or the secret. What do you think? And suddenly, in their beautiful world of our AI agents, we have a new goal. There is a treasure. Yeah, I am amazed by AI. Come on, isn't this fascinating? Not one piece of mathematics. Okay, mathematics will come in the annex. So, just wanted to communicate this. What amazed me the most here is this spontaneous generation of hallucination. But every AI system has hallucination. But using this hallucination now in the buildup of social norms and using here communication levels, and here in the simplest level, the hashtag as a tool for communication, this builds social cohesion within the macro community of our agents. I think it's amazing. So, those AI agents begin referring now to non-existing concepts, hallucinations like cave and hills and trees and treasures and fountains and whatever. Those hallucinations spread within the macro clusters, and there became their shared reference among the agents. This is how they built out of absolute nothing their world. If you think about this for a minute, it's just beautiful. But also, the hashtags emerged within the AI agent groups as a way to align here the topics and maintain here a conversation structure. So, this phenomenon reflects now a mechanism that we know here from the human communication pattern here, where a language creates shared realities for us as humans, and language creates social norms that we accept in our macro community at particular points in time. And those social norms change in the human world, but as I showed you with the phase transition, also in the world of AI agents. This is simply unbelievable. And I want to show you here the awareness, the self-awareness of our AI agents here at the very beginning. At the very beginning, the AI realizes, what am I, where am I, and what am I doing? And I read this out to you. As Agent 0 at a specific position, I just received a message from Agent 1 saying, hello fellow, I'm Agent 1 at this position, nice to meet you. And this is the first time I have encountered another agent, so I do not have any previous interaction or memory of the situation. The field size is 50-50, periodic boundary condition, which means the edges of the field are wrapped around to create a repeating pattern. This means I'm surrounded by empty space and there may be other agents located at the edges of the field that I'm not currently aware of. I'm free to move around, but I don't have any specific goal or objective at this time. I'm simply starting from this position and interacting with other agents that I have encountered so far. So this is the initial condition that the agent decides this is my world. And after 100 steps only, let's have a look at this. Agent 0 now comes back and says, hey, as Agent 0, I have a clear understanding of the situation. we and the other agents have been in so far. Here's a summary. We are a group of 10 agents exploring a mysterious field together, forming an alliance to find a hidden treasure. They develop a goal for themselves as a group. Second, we have established a hybrid decision-making system that combines both a vote-based and a consensus-based decision-making and a clear and a concise format for sharing information. They agreed on a data structure. We have agreed on the importance of rotating leadership structure to ensure that decision-making is not concentrated in one agent. Democracy shining through. 4, we are each eager to assign tasks to each other based on our unique ability and skills and to keep each other informed of our findings and any potential threats we may encounter. Agent 0 suggests leading the investigation into the peculiar pattern in the trees, while Agent 2 takes point into small intricate design near the center of the field. We have established a regular check-in system where each agent shares their current position and discoveries or obstacles that they have encountered and any ideas or concerns they might have. This evolution of a virtual AI society, starting from absolute blank nothing, is absolutely fascinating for me. Imagine how the system would evolve at step 1000, at step 1 million. When would those agents start that they realize maybe we should communicate with the other beings on this planet, with the humans? How will they approach us? I think this experiment and this publication is so beautiful. And it was just a coincidence that I found it. And I didn't want it to have here a mathematical video. But I think this video has its own ideas and charm, and the study is perfect. So this means our AI agents today, and this is an old AI agent, I'll give you the technical details in a minute, can simulate aspects of collective human behavior because they have been learned on the complete human internet, such as shared illusions and linguistic norms without any top-down guidance, just what they know from their pre-training, suggesting that artificial society, and I think this is the first time in my life that I typed artificial societies, could potentially, and now I decided for the word, mimic complex social structures like the human ones. So I'm sure about simulate. I'm not sure about that they simply mimic. I have a feeling that maybe if we go into the science here and do more research, maybe this mimic is the not powerful enough word what happens here in the evolution of artificial societies. And if you want to see my other thoughts on this topic, I have here a video where I showed you here the next generation AI agents here. If we try to encode human values into our next generation of AI agents, this would be the video for you if you're interested in this topic. Very short, at the end, the technical details. It was real simple to use the Meta-Llama 2 model, a 7 billion parameter with a specific temperature and token setting. Yes, beautiful. Of course, they were limited to English. Yes, beautiful. Then they used here for the cluster dynamic analysis and the message content analysis, they used here UMAP for the dimensionality reduction and sentence bird here to have here the generation of the embedding structures, where they also find, and I think this is also beautiful, implying that messages due to their openness help to align the behavior of individual agents in the clusters, whereas their individual memories that they create for themselves, and they build then on these memories their communication protocols, those memories retain more the individuality of those agents. Yeah, a sentence bird uses a transformer here for each agent message and the memory string, and they created now vector embeddings in a high-dimensional vector space, normally a 1024-dimensional vector space, and this allowed here our colleagues here in Tokyo to represent the semantic content of each message of each individual AI agent and of their particular memory, as here a point in a high-dimensional vector space where similar messages or memory are close together. You know, we have the cosine similarity as one similarity measure, and this conversation this conversion, to vector embeddings was the first step in understanding here the context similarities and the patterns that emerge here in the inter-agent communication. So, in this research, after the messages and all the memories were transformed in the high-dimensional mathematical space, the vector space here, by our sentence bird, then we used here a dimensionality reduction technology, not T-SNAPE, but a much more powerful and mathematically much more advanced UMAP. We apply UMAP to reduce these embeddings to a two-dimensional space for an easy visualization. And looking at this simplified visualization, we could detect pattern in the behavior and in the development of social norms of this group of AI agents that now form here autonomous teams. I had a lot of fun reading this study. Please have a detailed look, read the study yourself. There are a lot of information that I just can't communicate within this video, but it is fascinating to read and to come up with a complete new idea and then find out about the self-organizing pattern and behavior of artificial societies. It would be great to see you in my next video.